The Ararat region of Armenia, site of the Austrian Space Forum's training for the colonization of the Red Planet.
This is the latest Mars simulation station, where a crew of 6 analog astronauts will be performing tasks for a month that people in 20 to 30 years might one day do on Mars. It's like getting a sneak preview of the future.
An international team of so-called analog astronauts is testing newly developed equipment and procedures. The goal is to detect potential problems to ensure that the journey to Mars doesn't become a suicide mission.
I believe it's time for us to head to Mars. Mars is a place of yearning for us. One day there'll be cities on Mars. I'm absolutely convinced of that. What we're doing here is like taking the first small baby steps. We're learning to crawl before trying to walk.
In the past, space travel was a prestige project reserved for superpowers. Nowadays, private companies are transforming it into a viable business model, building rockets and seeking technical solutions to make leaving Earth more affordable. The path to the stars is full of highs and lows, but for these entrepreneurs, there's no turning back. They've been lured by the boundlessness of space and all its treasures.
There's so much out there. The universe is infinite. Infinite power, infinite prosperity. I just need to get out there and grab it.
The industrial area of Innsbruck is home to the headquarters of the Austrian Space Forum. Astrophysicist Gernot Grumer leads preparations for the private research organization's next Mars mission.
We'll remove the helmet and go through the sensors one by one to check the wiring to see if we can improve the routing a bit. Could you take off your helmet?
Yeah.
They're planning to add new features to the spacesuit simulator.
This is essentially a kind of spaceship you can wear. In the spacesuit, we can measure many things, starting with the astronaut's EKG, but also simple things. You can eat, drink, and even go to the toilet in the spacesuit. If there's one thing you want to avoid, it's sneezing in a spacesuit. It's a mess. So we have a small piece of fabric here where you can scratch your nose. These are small things that aren't high-tech, but they significantly improve the lives of analog astronauts.
Scientists have been refining the suit for over 10 years. The latest addition is a new set of sensors measuring the astronauts' level of exertion during the next analog mission.
This spacesuit simulator is unique in Europe. It's by far the best simulation tool we have for reproducing the stresses that people will one day experience while working and living on Mars.
Ever since his first glimpse of space, peering through a telescope as a child, Gernot Grumer has wanted to reach for the stars. To get closer to his dream, he became an analog astronaut, a researcher on Earth studying space travel.
We expect the first humans to land on the Red Planet in the next 20 to 30 years. That means that the person who will take the first step on Mars has already been born. In a way, we're a generation of shipbuilders, creating the equipment that will likely enable the most complex and dangerous journey ever made, that will one day lead us to a new world.
He puts on the so-called exoskeleton. Artificial resistance simulates the pressure conditions astronauts will face on Mars.
When I raise my hand, it stays in a neutral position, it doesn't drop. If I make a fist, it takes a bit more strength than usual. This way, I can precisely simulate the physiological stress patterns that a pressurized spacesuit on Mars would exert.
Since tech billionaires like Elon Musk started building rockets and exploring space as an economically viable undertaking, the industry has boomed. Numerous startups in Europe now aim to join the gold rush in space. We're on the road with Stefan Brieschenk, founder and chief engineer of Rocket Factory Augsburg in Bavaria. He's taking us to a former military site housing an old ammunition bunker. The company rented it to avoid paying for certified testing facilities. Rocket Factory encourages improvisation. Its aim is to build a rocket that's unbeatably inexpensive.
Yep, this is where it starts. What did you guys do with this coupling? Was this coupling rebuilt?
Yeah, it was rebuilt. So the flexible link here is the same as the one on the helicopter engine side.
We're running a critical test today. This test will show us if this turbo pump has the performance we need. If the performance isn't there, the rocket won't reach orbit.
Let's go. Let's go and run it.
For this test, the turbo pump is driven by a helicopter engine. Can it withstand the power of the motor?
That's an awesome sound, right?
The pump could get torn apart. Everyone has stepped back to observe the test safely. Stefan Brieschenk can tell by the sound whether it's delivering the desired performance.
The test went very well. A worthwhile investment today. We're gathering data. The turbo pump's improving, the engine's improving. We're getting closer to being ready to fly into orbit.
Rocket Factory Augsburg's headquarters are 30 kilometers away. Stefan Brieschenk started the company with a partner in 2018 at the age of 33. The firm now employs around 300 people from over 40 countries. Funding for the development of the rocket is being provided by venture capital. To cut costs, the company uses standardized industrial components.
There are lots of technical details that differ, but this is essentially a beer storage tank, like the ones you find in breweries.
Using a beer tank to reach space. It's an idea Brieschenk got from an AI. To build the rocket engine, his engineers are using automotive parts and components made by 3D printers. Before starting his company, Brieschenk studied aerospace engineering in Australia and worked in the industry for 10 years.
This is the heart of the engine. A rocket engine is a miracle of physics. It's amazing that it works at all. Space travel itself is an absolute miracle. No one ever really thought it would work. There were many mathematicians who said it wasn't possible to reach space due to the laws of nature. And then, over 60 years ago, the Russians proved it was possible by putting a satellite in orbit. And with that, space exploration took off.
Brieschenk's father was a helicopter engineer. Stefan set his sights even higher, choosing rockets instead. The ultimate challenge for any engineering enthusiast.
There are over 100 companies worldwide trying to do the same thing, to build rockets as cheaply as possible so satellites can reach orbit at lower costs and generate more data. That's why secrecy is important. But in commercial ventures, there's something even more important. And that's speed. You have to make it happen as quickly as possible.
Elon Musk's SpaceX led the way in commercial spaceflight, with the grand goal of colonizing Mars. For the moment, however, most rockets are meant to launch satellites into low Earth orbit. In 2023, the total number of satellites circling Earth topped 7,500. It's big business for rocket builders. This commercial use of space has been dubbed New Space, and Germany wants to be part of it. Its New Space initiative was founded in Berlin in 2021 as part of the Federation of German Industries. It's a market that's already worth billions, as more and more sectors depend on digital networks, as the initiative's leader, Matthias Wachter, explains.
These days, the exchange of data happens largely via satellites and space-based systems. That's why New Space is a key issue for the entire breadth of German industry, and why we're so committed to it. We believe it holds great potential for German industry and for the future and competitiveness of German industry.
Rocket Factory Augsburg is one of 3 German startups developing small rockets to transport satellites. No one is willing to show their hand, and everyone wants to be first.
We'll make it to space, and we'll keep going. Even when the odds are against us, we find a way to venture out, learn more, and answer the big questions. Why do we exist at all? Why are we here?
Stefan Breschenk likes to spend his evenings at the workbench in his garage.
I'm here every day, usually until midnight. Without this, my life just wouldn't work. Without this workshop, I wouldn't be able to get by. I need to do these kinds of things. I want to invest as much time as possible to move things forward.
He's convinced that new technologies will keep improving life on Earth. By day, he builds rockets. In the evening, he attempts to revolutionize the car engine.
I've been working on this engine for a long time, almost 10 years now. It sounds crazy, but I've finally proven that it works. A completely emission-free engine, essentially a combustion engine with rocket technology. We build rockets like cars, and here at home, I build cars like rockets.
A clean combustion engine, making the impossible possible, both on Earth and in space. Like Elon Musk, he's convinced that humans will become an intergalactic species.
It's crucial that humanity manages to set up a base on another planet, a place that's inhabited continuously from then on. That's the first step. Mars, the Moon, there are various targets, but Mars definitely makes a lot of sense.
Space tourism, colonies on Mars and the Moon, asteroid mining, the promise of limitless growth in the infinite reaches of space. Much of this still sounds like science fiction, but expectations are high. According to a study by the Federation of German Industries, the market for space-based applications could grow annually by 7.4% to over €1 trillion by 2040. A sandpit in Upper Austria, site of Gernot Grömer's public presentation of the Austrian Space Forum's upcoming mission to Mars. More than the romance of space, it's the multi-billion-dollar economic opportunity that officials say Austria should not ignore.
Space made in Upper Austria might one day become a brand. This could be seen as the birth of it all.
The Mars rovers are drawing special attention. Developed for the upcoming mission by Austrian and German students, They're designed to explore unfamiliar terrain as autonomously as possible.
Go ahead and drive. Today is Ready for Space Day. We're training to get ready for Armenia. Not everything's perfect yet, but that's why we do these exercises. There are still 5 months to sort out minor issues and hiccups.
For these students from Germany's University of Würzburg, it's an opportunity to meet other teams and exchange ideas. How's their project coming along?
Irma won't fundamentally change now. We've locked it in. Irma's main task is to scan for things, and she can do that well. We want to keep automating the whole system. The same goes for Charlie. Charlie drives more autonomously than Irma, but still not fully.
The general takeaway, there's still a lot to do before Armenia. In the hall, the analog astronauts are getting suited up, which can take up to 3 hours. Annika Melis is being fitted with the exoskeleton, which simulates movement under the pressure conditions on Mars.
I read an article in the paper at home which said that the Austrian Space Forum was looking for new analog astronauts. Because I find space travel exciting, I checked out the website, read it, and thought, oh, I have to try that.
Annika Melis studied microbiology and environmental engineering. Like everyone here, she's an analog astronaut in her spare time. Today, her colleague is from Italy. Annika's from Plauen in eastern Germany.
I'm looking forward to the mission. We'll see how it goes with all those sensors. We've already tested where they pinch a bit and how all that can work well.
The analog astronauts wear sensors under the 50-kilogram suits to measure their exertion while they follow various instructions.
You go slow to point 2. You can decide if you take a break before or you go directly. Copy. Please report in point 2.
I don't know if you can see, but I'm very sweaty. It's about 32 degrees Celsius in the suit, and the suit's very heavy, so every movement is exhausting. But I'm very satisfied because the sensors appear to have worked and picture quality was good. So we did what we planned to do, and things are okay.
New space is also garnering interest in neighboring Bavaria. Stefan Brieschenk is pitching its possibilities to representatives of Germany's Chamber of Commerce.
Elon Musk is going ahead and launching thousands of satellites into space to provide internet. The commercial use of space is just exploding right now. We want to build rockets like cars to get satellites into orbits. We're looking at a multi-trillion-dollar space economy.
Rocket Factory aims to launch rockets once a week, providing its customers with an inexpensive way to bring satellites into orbit. The Augsburg startup has partnered with the German Aerospace Center. The aim is to form a partnership between old space and new space.
This allows us to build on technologies that have already been developed here. In English, you would say,
"You're standing on the shoulders of giants."
Stefan Brieschenk hopes the space race collaboration will provide a competitive advantage. The government organization is impressed by the boldness of these young entrepreneurs.
New space brings a different mindset, one that ultimately helps make space exploration and its applications accessible, affordable, and relevant for everyone. Depending on how you calculate it, this will be a market comparable to the automotive industry.
Expectations are high, not only within the industry. students in Würzburg hope new space initiatives will create many new, interesting, and high-caliber jobs. Several months have passed since the trial for Armenia in the Austrian sandpit. What's the status of the rovers? Are they now ready for their extraterrestrial mission?
I'm very confident the astronauts in Armenia will have no problems controlling the robots.
The Mars mission will begin soon. 3 rooms away, their professor, Andreas Neuchter, is on a call with members of the Austrian Space Forum.
Oh, hallo Raimund, servus. Hallo.
The motivation in Armenia is incredible. We're seeing an amazing response from the local community, the media, and also on the political side. I'm really looking forward to it. It's going to be exciting.
Genau. Dankeschön, gentlemen.
Okay, danke.
Bis in 2 Wochen.
Okay.
And what's the status of Rover Charlie?
45 degrees left, 20 meters forward.
Desks by the window have become a control center. Will Charlie make it up the icy hill?
He'll make it.
The hill's been conquered. 3,000 kilometers further north, near the Arctic Circle in Sweden. Stefan Brieschenk is on his way to the S-Range Space Center, where Rocket Factory is performing full-scale combustion tests on its rocket engines.
We've been conducting major tests here for 3 years. The tests we do here are in fact the biggest and most dangerous tests that have ever been done in the site's history.
These isolated frozen forests are home to Europe's first spaceport. Rocket Factory has rented one of the testing sites. Its Helix engine, developed in Augsburg, is installed on the test stand. Today, they'll be performing a hot fire test, meaning that the kerosene-fueled rocket engine will be ignited, as it would during a real launch.
I'm very interested in seeing what's been done. I want to go over all the changes we made myself, to ensure we can proceed with this test today with a clear conscience.
Everything's ready for the test, just running a few test sequences since it's extremely cold today.
Today's test cannot fail. It has to succeed. What we're seeing here is the result of 5 years of work. There's engine number 2 and engine number 3. That is the 3rd engine we've ever built in the front position. If something goes wrong, 5 years of work will be wasted. If something goes wrong today, I'll just get up there and jump off.
Don't even think about it.
The startup's existence depends on the trust of investors. To maintain funding, they need to see positive results. The skies over the S-Range Space Center are closed to air traffic tonight, and security levels are at a maximum. The Helix engine produces 500,000 horsepower. If it goes out of control, there could be a real rocket launch. Ahead of ignition, officials order the area to be evacuated.
It doesn't get tougher than this. Attempting to pull this off at minus 30 degrees in the middle of the night will deeply affect everyone here. They'll still be feeling this a week from now. It won't just be over by tomorrow.
While some are leaving the area, others are performing final system checks. Then, an unexpected turn.
Okay, we need to abort. One regulator, it's heating up, but not enough. We can't reach the necessary pressure. This is the last step before ignition. It's one of the coldest test days we've ever had. We'll leave it for today and give it another try tomorrow.
Okay.
Welcome to the rocket business.
Delays are a fact of life in the business. But Europe is eager to become independent of SpaceX and Starlink, eager to develop competitive European launch vehicles. These will allow the continent to deploy its own low-orbit satellite internet system. But that orbit is already becoming cluttered with debris. Particles only millimeters in size can destroy a satellite. 9,000 tons of space debris already orbit the Earth. Only a fraction of the pieces is larger than 10 centimeters. Yet the many smaller pieces are also dangerous.
Space debris is a serious problem. This issue needs to be tackled much more proactively because there's a risk that space, particularly low Earth orbit, could become so polluted that we lose access to space in the long term. All spacefaring nations should be invested in this. I believe Europe could take a pioneering role here.
Space may be endless, but near-Earth orbits, vital for satellites, are not. These orbits are seen as key for the success of efforts toward a greener digital future. Were satellite infrastructure to fail, much of modern life would be paralyzed. The Austrian Space Forum is well aware of the issue. Commissioned by an investor, they're working on solutions.
We're now going into a more sensitive room. Here we're building, testing and developing hardware that will actually fly in space. This is not a simulation, it's the real thing.
Could you give me a hair gun as well?
Let's take a look at a sensor. The original is currently flying 500 kilometers above us, searching for space debris. It detects the smallest particles moving at high speeds in low Earth orbit. But in our case, we want to be hit.
The Austrian Space Forum has specialized in tracking the smallest pieces of space debris. To do this, they developed special circuit boards that listen in space like a microphone. If this technology works, the investor plans to start a company that collects space debris data and sells it to satellite operators.
Here we see part of a sandwich structure made of fiberglass composites with conductive elements. This allows us to detect the tiniest pieces of space debris, which can cause damage, though not as much damage as a fist-sized object. We can track the millions of tiny particles that float around up there.
In the spring of 2023, the Forum launched its second research satellite into orbit using an American rocket. At the end of its lifespan, Adler 2, like its predecessor, will burn up in Earth's atmosphere.
That was thrilling, as was our launch with SpaceX and, for our previous satellite, our launch with Virgin Galactic. That thing went up 500 kilometers. I've never been so glued to a monitor, biting my fingernails. The second launch was a bit smoother. We already had more experience and more trust in our colleagues. We launched with a Falcon 9 that time, deploying several small satellites at once, and by chance we saw that our satellite was deployed near Armenia. It all came together so nicely. So when we do our Mars simulation in Armenia, we can use our own satellite to take our satellite images. It's an amazing feeling when two projects come together like this.
At the foot of Mount Ararat, near the village of Armash in Armenia, the Austrian Space Forum's Mars mission is set to begin. A visitor check-in station has already been set up. 2 employees stand guard, keeping out any unwanted guests. Gernot Grömer is already on site. He heads to the test area in an off-road vehicle. Why did he choose Armenia?
We know there are geological formations here that are geological twins of those on Mars, so-called geosimilars. That's the reason we came here.
Eli, Gernot on loop 52. Elo, Gernot on loop 52.
After checking in at the village, Gernot makes a second stop.
This is the checkpoint.
This is the checkpoint. This is part of our security detail. They're here 24/7, guarding access to the test site. Cameras are set up on all the surrounding hilltops, so we have round-the-clock surveillance.
The region recently experienced conflict over Nagorno-Karabakh. No one wants to take any risks. Security provisions are in place, but despite meticulous planning, not everything is running smoothly. The Armenian partner didn't complete the infrastructure in time.
What are you doing?
I'm not sure what Hamid is doing.
Hamid, what are you doing?
Restarting.
Okay, that's fine.
Lack of internet access is causing issues. The teams from Graz University of Technology and the Würzburg Institute for Informatics are looking for solutions.
We need to enter something here. A gigabyte, maybe?
A gigabyte is very little.
Really?
It should be here, but it just says Roslog or Rosdep.
If communication on Earth is this challenging, how will it be in space? At least the Graz University rover is working.
It's still a long way to Mars, but we at the university are also interested in researching the fundamentals. It's important to test each individual component.
Rover technology is driving innovation in fields like robotics, sensors, and communications. These fields are benefiting from funding provided by national and European sources, such as the European Space Agency, as well as private donors.
It's no simple task, and if we went to Mars with what we know and can do now, it would be very dangerous and probably not very productive scientifically. That's why we need to learn in Mars-like environments how to best utilize our resources. It's exciting.
But the Mars mission is delayed. Even the habitat where astronauts are to live and research on site isn't ready yet. Hayek Aslanyan, a member of the Armenian team, faced unexpected challenges. Instead of conducting research, everyone is setting up. Gernot Grömer prefers not to speak about the mission's challenging start. Analog astronaut Annika Melis also didn't expect her sabbatical to go like this.
It's stressful. There's always that period in the first few days before everything officially kicks off, where things aren't running smoothly yet. But I've never experienced it quite like this before.
While some are struggling with the situation, others are tackling it with gusto. 2 Armenian members of the mission are setting up a Wi-Fi connection.
I'm interested in space because I'm majoring in engineering, and my main goal is to have my own impact in the space industry.
I think when we are all young and we are like still child, we always want to become an astronaut. We have that passion of exploring everything, and I think that's why we are so interested in science. Everyone. Yeah.
Hayek Aslanyan has big plans too. In Soviet times, Armenians were involved in building Sputnik, the first satellite, and the first Mars rover. Now he hopes this mission will revitalize Armenia's role in space exploration.
To make a new, bigger dream, and when you look at the Ararat, you can see how big is it. So our dream should be bigger. Yeah, otherwise, I don't know why we are living.
It's better at parking than I am.
At the end of the day, the Graz team hands over their rover to the Space Forum. The futuristic vehicle has inspired a group of Armenian students dreaming of a promising future in the space industry. Up north, the temperature has risen dramatically. Instead of -30, it's now only -15 degrees. The weather's no longer an obstacle. The test is a go and has to succeed. Stefan Brieschenk wants to get an update on the pressure regulator that caused problems yesterday from test engineer Jonathan Ross.
Okay, here's the man, Jono. Where is it?
And normally this works. Well, yesterday this one didn't work, but they normally work down to about -15 minus.
Are we late then for today? Or
No, we're good. Okay.
This is a heating cable we managed to get this morning. It ensures that the whole regulator stays warm and all the seals work. It's a shame we couldn't run the test yesterday because we didn't have this one component.
Stefan Brieschenk brings the pressure regulator, now fitted with better cold insulation, to its designated spot beneath the engine. He doesn't want to leave anything to chance.
Ja, jetzt sieht's gut aus. Yeah, ready to go. Ready for this hot fire today.
Rocket engines always push components to their limits. If even one part fails, everything can end in a fiery explosion.
Working on a project like this is absolutely unique. There are few jobs out there that spark as much motivation as being involved in a rocket launch. The people are passionate about it. There's nothing more important to them.
Time for final instructions in the control room.
Try to not leave the room, no chatting, no questions asked to the operators, everyone's in full concentration. All upper and lower bounds should be called by a red line. I will then call the abort correct, yes.
The final countdown.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
The engine shuts off unexpectedly. Was there another problem? The goal was to fire the engine for 160 seconds.
So what I saw on the camera is that it looked like that a few of the sensors were probably blown away by that pipe, or probably by the gas, and I think that's why a few of the sensors have failed.
After 20 seconds, the controller stopped the test. Space travel is incredibly difficult. Everything is at the absolute limit, so we engineers, we as a team, have to test as often as possible to push things right to the edge.
Their safety system worked. The engine didn't spin out of control. But the goal everyone had set their sights on, 160 seconds of continuous operation, remains out of reach. The northern lights shimmer in the sky. The same sky Stefan Brieschenk hopes to reach with his rockets one day. In the space industry, emotional highs and lows are close bedfellows. Anyone working here needs to handle frustration well. Even Elon Musk didn't succeed every time. For Stefan Brieschenk, there's no turning back.
Everything about rocket technology is so incredibly difficult. You're working so close to the limit that, in the end, you find yourself getting very close to the laws that God, or whoever created the universe, has set. And then you realize that while these laws are fixed, you can get much further than you originally thought.
Back to the Austrian Space Forum's Mars mission. The space habitat may not be finished, but 2 analog astronauts are being prepped for their first extravehicular activity. Soon, a 6-member crew is set to live in these quarters in isolation for 4 weeks.
Then you do the check with safety.
Today we're just going to do a short exploration around the habitat and try to see what the ground's like when walking and so on. Take photos and do a brief drive with the quads to see how well they work, so it's just a short first test.
They themselves will probably never make it to space, but they feel they're part of a larger mission.
When the real Mars expedition happens, I might already be retired. I'll be able to say, I put in the screws. But my younger colleagues might be in the middle of their own careers by then. They've already built a bridge to the future. Being involved in this, I think many people in our line of work consider that a privilege.